In this lesson, we're going to look at how to assign data to an array and then access that data. I've already shown you how to do it via the initialization route, so let's look at a different way. First thing we're going to do is declare an array of 5 elements, call it grades, and then we'll just begin assigning data into the array using very standard assignment statements. So notice we use what I call array notation or subscript notation to reference each element of the array. So we'll finish this up here. So when we have an array of 5 elements, the first element is going to be index 0. The second element will be index 1. The third element will be index 2. The fourth element will be index 3, and the last element will be index 4. So just like with vectors, we always start our indexing at position 0. And so we call that the 0th position of the array, the first position, and so on. Or the second position. You can call this the first. It really doesn't matter how you name that. It's very useful when working with arrays to have a constant. Whoops. Let's call this G size, because we're going to need that when we loop through the array. Because unlike vectors, arrays don't have a built-in function to tell us the size of the array. We have to carry that around with us, as I say. So if I want to compute the average of this array, I'm going to have to do this. Hang on, let me set some variables up here. So I'm going to use a loop just like we always do. And here I don't know, I can't use the array to tell me the size, so I have to use this constant G size to tell me that. Then to access each element, we're going to use just standard array notation with the loop. So index variable I is going to access each element of the grades array from 0 through 4 to get all 5 elements. And then to compute the average, we'll just say average is equal to sum divided by G size. And that's why we need a excuse me, that's why we need a variable or a constant, because we're going to use that quite often. So let's run this program. Taking a minute to compile. And the average is 82, which looks reasonable given the spread of grades that we have here. If we need to change a grade, we can of course access it at any time directly. Then we'll need to compute all over again. So we'll just take all this part, add it to the bottom. Let's keep both in there. You just set the sum back to 0. Always have to be careful when you cut and paste. Whoops, excuse me for that. Get right back here. Give me a second. There we go. Oops. Excuse that too. It's going to take a second here. There we are. Now we're back. Let's run it again. So see, the average went up when we changed one of those grades. So again, the way we access and assign is via subscript notation. So here's an example of assigning grades in originally. We can use a loop to access each grade in the array, and then of course we can change a grade directly if we need to using assignment. And with that, we've wrapped up this lesson on assigning and accessing array values.